Hi good people, my name's Titus and today we're going to try to recreate the classic game Pong. This was one of the earliest arcade video games that was created as a training exercise by an Atari engineer in the 70s. I think this makes it a perfect exercise choice to test our game development skills. Let's not waste any time and just jump right into it. Okay, so I have a blank project with no starter content here. So the first thing we're going to do is let's come to the content folder and we'll create a new folder. And we'll just call this _ controller. So I think the first thing we'll do is we'll work on creating the paddles, which are used to basically send the projectile or the little Pong ball back and forth between either another player or an AI. We'll actually set it up for a player first, but then we'll also code in the AI at a later video. So let's go into the controller section here, and we got to create some actions, and then we'll have to create a mapping context. So let's right click, go under input, we'll choose input action, and the first one we'll do is IA_move, and then we're going to create another input action that we'll call IA_spin, and we'll create one more that we will call IA_boost. So our three actions will basically be moving the paddles, then we'll give the player the ability to kind of flick the ball like a spin move, and then we'll give the ability to the player to actually accelerate the paddle, up and down if they need to. If they, need less fine control, they just need to, get to a point quickly. Now creating the actions is one part of it, but we have to also create a mapping context. For this project, we're just going to have one, but in other projects, you can have multiple input mapping contexts, and you can actually switch between them dynamically. So that can be helpful. Think of like Halo Combat Evolved, where you had one controller scheme, and then when you got into a vehicle, it was a different controller scheme. That's sort of what IMCs are used for. Now, when we double-click these, you'll see they're pretty basic. They're just set to digital bool. And this one is the boost. This one's the spin, and this one is the move. For the movement, we're going to be using the WSAD, and I'll use a controller joystick, so we can't use a digital boolean. We're actually going to be using an axis 1D float because we're only going to be tracking, in this case, it'll be the y-axis. So I'm going to switch that to axis 1D, and then we will save, and then we are actually good, and we can close out of those. Now we can right click, go back to input, and we will create our IMC, or input mapping context. This one I'm just going to call default. Like I said, other projects you can have multiple. For this simple prototype, we're just going to do one. So I'm going to hit the plus sign to add a mapping, and then I can assign the action to that mapping. So the first one we'll do move, and then we can basically code in the actual movement. So I'm going to set the first one to be the gamepad, and I'll use the left thumbstick. I'm going to do the y-axis, because the paddles in Pong, they only move up and down. They don't go left and right. So we only need to track, one-dimensional axis on that. Then I'm going to hit the plus sign to add another key binding. Obviously, I'll hit the little select key value, and I'll just type in W, and that's going to be the up value. And then if I hit the plus sign, I can hit the key value and do S. This is going to be the down value, so we can add a modifier, and the modifier we want is negate, which will basically make it a negative float value instead of positive, and that'll be how we track, the paddle going down. It'll be basically a negative value. And that pretty much completes our movement setup. The next thing we need to add will be the spin. And we can assign the key for the spin. I think for the gamepad, we'll just use the A key, which is the bottom facing key. And then I will add maybe the F key on the keyboard. So that way we can do it on the controller and the keyboard. So we got the move, we got the spin, and then the next one will be the boost. So I'll hit the plus sign again. We'll assign it to be boost. And then for the default, I think I'll use the left trigger on the gamepad, and then I will add maybe the shift key for the keyboard. And you can assign these like whatever you want to use. This is just kind of basic stuff right now. So we have our IMC set up, so we can save this, And now we can probably actually create our new level. So let's go File, New Level, and I'm just going to do an empty level with no lighting or anything in it. Now let's come to our content folder and let's right click and create our first blueprint class. We need this to be like a player character, so it needs to be able to possess input from a controller. So you can use pawn or character in this example. We cannot use an actor, so I'm going to select pawn just because I don't need a lot of this other stuff that the character comes with. So we'll do BP underscore, call it just player. I can double click and open this up. I'm going to add a single component, and it's going to be a cube, and I'm going to call the cube my paddle. Doesn't look very much like a paddle, so what we can do is come into the scale, and under the X value I can maybe bump that to 3, and there you go, that looks like a paddle. I'm also going to drag this up and replace the default scene root, and just make this the primary root component for this blueprint. Now we're going to be handling movement using a scalar value, so I need one variable starting off, so we can come to variables and hit the plus sign, and then I'm going to call this my movement scalar, and movement is typically going to be a float, so I will set the data type to be a float. I will compile, and then on the right hand side you'll notice that the movement scalar value shows up, so we can actually set it. Starting off I found 20, I think works pretty good, so I'm going to put 20, and then I'm going to compile, and that's going to basically set that part up. So now we can come to the event graph. I'm going to delete all this stuff for now, and we're going to just do we're basically just going to get the paddles moving in this video. So we created the input actions, we created a input mapping context, so now we need to tell our blueprint to use that context. So Unreal Engine now has a new method to do that, and that is the receive controller changed event. So this thing right here. So we can pull this here, and then under the new controller, we can pull that into a cast to player controller. And then from there, we can pull off the blue pin, and you can search for enhanced input local player subsystem, and you'll want to do the bottom one for get, or get I should say. And then once you have that, you can pull off the blue pin again and do a add mapping context node. We'll hook up the successful cast function here into the add mapping context, and now we just need to assign the IMC that we created earlier. So on the drop down, our IMC default shows up, so I can just select that, and with that our controller will start reading input from this blueprint, so we can actually do things with that. So the controller's assigned, but we have to tell it, we have to basically code the logic, basically what to do. So the blueprint can see that the controller's mapped and that the buttons are pressing, but it doesn't know what to do when you push those buttons or move those joysticks, that sort of thing. So for the first one, we will do IA underscore move, and then I'm going to choose the event function for that one. So we have a little red node here. And then you notice we have a single action value. That's because we are using a one-dimensional float value in our input action. So when we went into move and we created that axis 1D, that's why there's only one value there, just because that's really all we need. Now I don't really want to do it when it's, yeah, I guess we can use it when it's triggered, that's fine. So when it's triggered, we will basically want to set the world location. So I can drag the paddle, so I do a get off that, and then set world location. So we have that there. So I basically need to get the paddle's current position. So we can drag another reference to paddle, and then we can use the function get world location. And under the transformation node here, it's going to come back with a vector. We're going to be doing different things. A vector is basically an X, Y, and Z. We're going to be doing different computations on each pinout. So the way we do that is we have to right click and split the struct pin. That way we have access to the individual X, Y, and Z. Now for this prototype for Pong, it was a 2D game. Unreal Engine is a 3D engine. We are not going to be doing anything with the Z axis, so we'll likely be locking that down. But we will be doing, in this case, we're going to be using the X axis for this example anyways. So I can pull off my action value and come into a multiply node. So I'm going to multiply my controller input by my movement scalar that we created earlier. And then we can add this to the existing X value. So basically get the current location and then add this to the current location so it moves. And then we can just pass this into the vector if we right click and split it. And then I'll pass this into the X variable here. Now we don't want the Y and Z to be 0. We want this to match what the current values are. In the case of the Z, it is 0, but just for good practice, we can just pass it in just to make things easier. And this pretty much completes the movement part of it. So now if we go back to our level here, and let's actually save our level. So we'll do save current level as, yeah, we'll just call it level 1. Looks good. Now if I play the scene, nothing's really going to happen. You see it creates this default pawn, which is not our player pawn, and then it does so based on this game mode kind of base thing here. So let's go ahead and stop playing. We can't really see or do anything. If we go to our project settings and then under maps and modes, and then under selected game mode, you can expand that out and it gives you everything that's going on. Like right now we're using the default game mode base, which preloads in a default pawn and a HUD, player controller, all that good stuff. We want to override this with our own settings. So to be able to do that, we need to create like a game mode. In our case, we're going to title it a game manager. So let's do that real quick. We'll right click, we'll do a new blueprint class. I'm actually not going to select game mode base. I'm going to go to all classes, search for game mode, and under game mode base there is just a regular game mode. I'll select that one. I'll call it BP underscore, I'm going to call mine game manager. And then if I double click this, I can actually edit those fields that we were looking at earlier. So for my default pawn class, I don't want to spawn in the default pawn, so I want to set that to be none. We might change that in the future, but for now, we don't want it to be doing anything. So now I'm going to compile and save this, and then I'm going to go into my project settings, and I'm going to override the default game mode to use that game manager that we just made, and that way the default pawn class is now set to none. So now when we play the scene, nothing's going to happen, but it also won't spawn in that default pawn there. So we could put in our own pawn, which we might as well do now. So now let's go ahead and add in our blueprint for our player. I'm going to reset the location by clicking this little arrow, so it's at 0, 0, 0. Now we need to be able to see the the little paddles, so we want to add a camera. So I can just search for camera here, and then I have a camera actor. So I can drag that into the scene. I'm going to reset the position. If I drag it up, actually, I want it to be pointing down, so I am going to rotate it by 90 degrees. And I want to set the projection mode from perspective to be orthographic. And then for the orthographic width, I'm going to use something pretty far, like maybe 5,000. And then you can kind of see it there, but because there's no lighting in the scene, it's basically dark. So we can add in a light, but another way to get around this is we can just use emissive materials for now. So I'm going to right click and create a new material, m_emission. Get that so that flashing goes away. And I'm going to press 3, click into here, press M, click there, So 3 gets me a scalar 3, M gets me a multiply node. You can also get it from your palette over here, or you can right click and search for these various nodes. This is a constant 3, this is a multiply node. So I'm gonna plug this into the multiply node. I'm gonna multiply it against 100. And then I'm gonna set the color from black by double clicking it. I'm gonna set it to white. Now I'm gonna click on my material, and instead of the blend mode being opaque, I'm gonna set that to be translucent. Then I'm going to pass this into the emissive color, and there it's super bright, and that's kind of what I was looking for. So now I can go back to my player blueprint, and I can select the paddle. And then if I just highlight the emission, I can just hit the little arrow to load it in, and now it's super bright now. So I can compile, and now suddenly if I click on the camera, you can see that's super bright, and it actually shows up now. So now if I play the scene, you see nothing's happening. So what we have to do is, even though we loaded a camera into the level, we never coded any logic on the blueprint or anywhere to tell it to use the camera. So it basically has no idea. So what we can do is we can click up here, and then we can open the level blueprint. And then under the, I'll go ahead and delete tick because I don't think we're gonna need that. But under the event begin play, we need to basically control that player pawn that we spawned. So we will do a possess, and if you uncheck the context sensitive, you'll see there's a pawn function called possess. And now we just need to get a target and the pawn to possess. So for the target, you can just pull off and do get player controller, but you need the one for the game state, and you see this one's for the player state, which will not work. So let's check context sensitive, and then here's the get player controller for the game state. You'll know you have the right one because it has this little player index, which players or index 0 is player 1. Now for the pawn, that one's a little trickier. What you have to do is you have to select your blueprint that you added in the scene. And let me just come to unlit so we can see it here. So basically highlight it so it's selected in your level. And then inside your level blueprint, you can just right click, and then you can create a reference to it. Now that I have my reference, I can just pass that into the pawn. So I'm basically telling it, hey, when the game starts, find this pawn in the level and then possess it for player 1. Now we need to tell it to use the camera because, like if I play this again, you can see it knows to take over the pawn, but it doesn't know where, the correct viewport or which view to actually use. And the player blueprint doesn't have a camera in it either. So the way we can get around that is we basically select camera. So this actor here, so it's highlighted. Come to the level and then right click, and then you'll create a reference to the camera actor. And then you can pull this into a set view target with blend. If it doesn't show up, just get rid of context sensitive. There, it shows up right there. And this will be the new view target. The blend time will be 0, so it does it, instantly. And then after possess, we can basically just call this into here. And then we just need under the target, get player controller. Again, we cannot use player state, we have to use game state. So make sure context sensitive is checked. And then under game state, get player controller. So now if we compile and save, and then if we play, we suddenly have a paddle, and it looks like our controls are not working. So we have to figure out what's going on there. All right, so let's go back into our player character. So when we did the enhanced input action move, we never actually hooked up the execution pin. So it was set up, but it was never executing. So let's compile and save and try that again. All right, so we have a paddle, and the W and S key are now moving. If I use my joystick is moving it as well, which is perfect. But now we need to get 2 players. So we're almost there. So to be able to do this, we are going to move this paddle over. So I'm going to set this to maybe -2000, so it kind of shifts it to one side, and then I can add in another player. I'll reset that to world origin, and then I'll set that to be +2000. So it moves it, kicks it over to the other side there. And then we basically need player 2 to be able to possess this. So that's going to be more of the same. So in the level blueprint, we can basically move our camera logic out a bit. And then after possess, we need to create player 2. So we will create local player. And then controller ID, if you use a negative value, oh, it even tells you a value of -1 specifies the next available ID. So if you don't know how many controllers you're going to use if you're making a project, just use -1 and it'll basically just kick out to the next available one. And then we can pull off this into the possess. And then we'll kick this here. And then I will actually move a reroute node there, so that's a little bit nicer. All right, and then we need our pawn. So the way we do that is we basically just have to select player 2 in the scene, and then right click, create a reference for the level blueprint, and then pass that into the pawn. But there's another step we need to do, so this is gonna look a little weird. So now if we play this, you see this is very strange. And it doesn't work if I use my joystick on my controller or the keyboard. It only moves to one side. So what's going on here? To be able to see what's going on, it's probably better if I add some lighting. So let's go to our window. We'll do the environmental light mixer. And then I'm just going to add all these options and then switch to lit mode. And then let's play. And now you can probably see what's happening. So we are currently in split screen. So player 1 has the logic to use the level camera. Player 2 is split screen. There's no logic for that player, so it's just defaulting to a view of the actual pawn. So instead what we want to do is come to our project settings, and under maps and modes there's a local multiplayer. The use split screen option is on by default, it looks like, so just uncheck that because we're sharing the same game screen for both players, so we don't need to split the screen for this particular project. And then there's an option to skip assigning gamepad to player 1. I want that enabled so my player 2 can grab the other controller. And then just with those changes, you'll notice now suddenly it's working. So it's one camera. Let's go ahead and get rid of the lights though, and we'll give this a test. So I am going to select all this stuff here, delete, and I'll go to unlit. And the nice thing about orthographic too, if you didn't know, I can actually reset the camera position to be world origin. You can basically put the camera wherever. It just has to be rotated correctly, and whatever orthographic perspective you set, it'll still work. So you don't need to worry about camera positioning, as you can see here. So now when I click in the world, my keyboard is moving the left paddle, and my controller is moving the right paddle. So that is working. Now one other thing that we'll want to do before we kind of kick off this video, the paddles can go off screen, so we might want to fix that. So what we can do is go into the player object. We will temporarily create a tick event, and then I'm just going to grab the paddle and get world location under the transformation node, and we'll pull into a print string, pass this in over here, compile, and we can play this again. If I move up, you can see the X values, what's changing here. It looks like around 1300 on the X value is about the top. And then on the bottom, I would assume -1300. Yeah, I think -1300 is a good approximation for my screen. So what I can do is just go to the actual logic here, and I'm going to delete that tick code because we don't need it anymore. I can just move the movement code out a bit, and we can pull into a clamp float, this one right here. And then I'll place this node here, and we will just clamp the values between -1300 and 1300. That way when you compile and you play, you'll notice that, you know, the paddle will no longer go off screen on either side. It's basically just kind of stuck there. And that's a smaller screen there. If I go back to the main window, it should keep the aspect ratio, and it'll still basically function no matter what the screen size is. But all right, everyone, I think we'll cut the vid here to try and keep these relatively short. But in the next one, we'll work on creating the ball so we can hit back and forth with paddles. And I hope you found some informative value in this topic that you can take into your own projects. But as always, thanks for watching, consider subscribing, and we'll see you on the next one.